Hello everyone, today we will solve LeetCode problem number 199, binary tree right side view. In the problem, they have given that we need to find right side view of given binary tree from top to bottom. Imagine that you are seeing this binary tree from right side. Then the nodes which are visible from the right side, we need to return from top to bottom order. For example, here we will return this 1, this 2, this 3, this 8 and this 9, because these are the nodes visible from the right side. So how we can solve this problem? Basic logic behind this problem is that for a particular level, here I have mentioned the level from, I have started the level from 0. This root node is present on 0th level and the lastmost leaf node is present on 4th level. So for particular level, we need to find which is the rightmost element in our binary tree. So here we can see for 0th level 1 is the rightmost element. For this level 1, 2 is the rightmost element. For this level 2, 3 is the rightmost element. For this level 3, 8 is the rightmost element. And for this level 4, 9 is the rightmost element because there is no node present on right side of it. So this is how we can solve this problem. Now we understand how we can approach this problem. So in order to travel through this tree, we require some traversal technique. We can't use our normal traversal because the problem is asking us for right side view, and to find this right side view, it is more easy to go from right side first, and after visiting this right side, go to the left side. So we will start traversing, like first we start from this root node, then go to right side of this root node, and after visiting all the nodes in the right side, we will go to left side of this tree. So this is how we will travel. First we travel to right side and after that to left side of the tree. And while traversing through this tree, for each level we will check, is this the rightmost element in this binary tree? And if it is the rightmost element in this binary tree for that particular level, we will add it in our result array. So here I will create one result array. So initially we are on this root node 1. For this 0th level, 1 is the rightmost element. So we will add this 1. After that, we will jump to this 2 in the right side. And as we are traversing right side first, so this 2 is the rightmost element for level 1. So we will add this 2 in our result. From this 2, we again go to right side of 2. So for this level 2, 3 is the right side element. We will add this 3 in our result. And this 3 is the leaf node, so we will return from here and go to left side because we have cover right side. So we jump to the 4. So now we jump on 4 and check whether this 4 is rightmost element or not. How we will check this 4 is rightmost element or not? Simply by looking our result, we can see that we have added total 3 elements. So if we have added 3 elements, then it it shows that we have added element for level 0, level 1, level 2, because our indexing start from 0 level, and currently this 4 is lie on second level, and we have already added element for second level which is 3. So we can't add this 4 in our result. So we will jump from this 4 to right side of this 4 on 8. Now we again check, is there any element we have added in this result for this level 3? So if we check the result array, in that result array we have added total 3 elements for level 0, 1 and 2. But for level 3 we have not added any element. So we need to add this 8 in our result. So I will add this 8 in our result. Now we have added for level 0, level 1, level 2, level 3. This 8 is present on leaf. Now this 8 is leaf node. So we will return back from this 8 and go to left side of this 4. But on left side, but the left side of this 4 is empty. So we need to return back from this 4 to 2. For this 2, we have visited both its right side and left side. So we need to return back from this 2 to our root node. So for this root node, I have visited all its right element. Now I have to travel in its left side. So I will jump to this 5. Now we will check whether this 5 is the rightmost element for this level 1. So our result contain total 4 element, and these are the level for which we have added the elements. So for one level we have already added 2. So we can't add this 5 because 2 is the rightmost element. So we are not adding this 5 in our result array. Now we will jump to right side of this 5. Now we will check whether we can add this 6 in our result array or not. So 6 is present on second level. We will check whether the second level is occupied in our result array or not. We can see that second level is already occupied in our result array by 3. So we can't add this 6 in our result array. So from the 6 we can't go to right because right side of 6 is empty. So we will go to left side of 6. Now we will check whether we can add this 7 in our result array or not. 7 is present on third level, and in our result array we have added element for third level, which is 8. So we can't add this 7 in our result array. So we are not able to add this 7 in our result array. Now we will try to go in right side, but right side is empty. So we will go in left side of this 7. Now we will check whether we can add this 9 in our result or not. So our result array is having size 4, and we have added for level 0, level 1, level 2 and level 3. But we have not added any element for level 4. So we need to add element for this level 4. So we will add this 9 in our result array. So this 9 is the leaf node. So we need to go back. Now we come to 7, and we have visited both its right and left node. So from this 7 we will go back to 6. After this 6 we will go back to 5, and after this 5 we will return to root node. For this root node, we have visited all the right side element and all the left side element. Now our traversal is completed, and we have collected all the rightmost element in this tree. So we can simply return this result at the end. So to summarize this thing, what we have do, we have traveled from right to left side. After that, we check for particular level, is there any element present in our result array or not. If the element is present in our result array, then we are not adding the element in our result array. And if the element is not present for that particular level, then we will add the current node in our result array. To check whether the element is present in our result array for particular level, we have used length of result. And if this length of result is greater than our level, then we are not adding the current node in our result. So the condition is, if our lane of result if our lane of result is equal to level, then we will add element in our result. But if this condition is not satisfied, then we are not adding the root node. So let's see how we can solve this problem on LeetCode code editor. So to store the result, we require result array, which is initially empty. And to solve this problem, I will create one helper function right side, def right side. And in this function, we will require root and level. And if our root is none, then we will return the root. If not root, then we'll return none or root. Anything you can return because both root and none are same. And as we have discussed, if our lane of result is equal to our level, then we will add our current root value in our result. So root dot val. After that, we will go right side first. So right side root dot right and level plus 1. And when we travel through right side, we go to left side. Right side root dot left level plus 1. And at the end, we will simply return the root. This function will append all the right side element in this result. So we need to call this function right side root, and initially the level is 0. After that, at the end, we need to return the result. So let's check whether our code run or not. So our code is working fine. Let's submit it. So as you can see, our solution get accepted successfully. If you have any doubt regarding this solution, then let me know in the comment section. Thanks for watching.